Okay, 1, 2, 3, 3, 2, 1. We're back again with another Codewars exercise in Python called Sum2total. Given a list of numbers, repeatedly sum adjacent pairs of numbers until only one number remains. So you're going to be given a list of numbers, and it says repeatedly sum the adjacent pairs until only one number remains. Now looking in here, let's go scroll down. Scrolling isn't working. All right, what's going on here? Come on, man. Weird, the scroll isn't working. So I'll have to refresh. Technical weirdness, my people. Okay, now it works. All right. If the list is 1, 2, 3, 4, 5, the first step would be, see, we are summing adjacent pairs. So we're going to sum 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5. And what you do, it doesn't really say this, you are going to generate another list of the pairs. So if you start out here, 1 plus 2 is 3, 2 plus 3, 5, 3, 4, 7, and 4 plus 5 is 9. So after this first pass, you're going to have 3, 5, 7, 9. And that'll be the result of all four of these additions. So that's what you produce on your first pass. And it says repeatedly sum until only one number remains. So once you get this, you're going to go in again and sum the next set of pairs. So moving down here, take the results from the first step and repeat the process of adding adjacent pairs. So now you have 3, 5, 7, 9, and you do, I'll just go through this again. You have 3, 5, 7, 9, and that produces 3 plus 5, 5, 7, and 7, 9. You've now produced this new list of 8, 12, and 16. And then it says continue this process until only one number remains. Now you have 8, 12, 16. You do your adjacent pairs. You got 20 of those two, and then 28. That leaves you with 2. And then, of course, you sum those two and you get 48. And you can see if you scroll down, or if I scroll down, because I'm doing the scrolling down here, you get 48 at the end. But that is what you do. You're starting with the list, you sum the adjacent pairs, get a new list, and then from that list you sum the adjacent pairs again, get another list. You do this process over and over again until it boils down to a one element list or one number. Yeah. And there you go. And if you come down, oh yeah, there's a couple other ones, but there's no breakdown. I'm just gonna get into the code, god damn it. Let's go. I'm gonna train again. So ARR is gonna contain a list. And one thing to know is if the list only contains one number already, I'm just going to go ahead and return it because I don't have any summation to do. There's no adjacent pairs to add. So if the length is 1, I am done. Yeah, if it's done, if it's 1, it's done. There you go. And then, so if it is more than 1, then I'm going to loop through and sum my adjacent pairs. And I'm not only going to sum the adjacent pairs, I've got to do it over and over again. I've got to get my next set of sums, do it again, get my next set of sums, do it again until I only have one number remaining. So this is going to be a nested situation because I need to have an inner loop where I generate my list of sums, and then the outer loop that says while this list of sums has 2 or greater numbers in it, I'm going to keep looping. So really, if the length of the list that I generate is not 1, I'm going to keep looping. So I'm going to do a while loop. The whiles allow you to customize the condition pretty damn well. I'm saying damn a lot today. But yeah, while the length is not 1 of this array, I'm going to keep getting my sums. And for brevity's sake, or to save a little bit of space, I'm going to do a list comprehension here, where I'm going to, I'll just let this play out and then I'll explain for my peoples, strictly for my peoples. Okay. All right, so we got a little list comprehension action going on here, and in this list comprehension, I'm doing my repeated adjacent sum list creation. That's what I'm doing here, creating a list. Creating the list. Can't say it right. Okay, so I'm going to loop through the list, and I'm starting at index 1 because I'm going to be looking at adjacent elements. So let's say my list is something like this. I start at element 1 so that I can sum 2 and 1. Then I can sum 3 and 2, and then 4 and 3. That's why I'm starting at element 1 and going to the end. And you see here in the body of my list comprehension, I'm going to get the sum of the previous element plus the current. So on the first iteration, it's going to be the 2 plus 1. And that sum is going to become an element of the list as per its location in this list comprehension. So my sums are going to be the elements of the new list. And I'm using ARR as the new list. So I'm using the old list ARR as the source, and then I'm putting it into a new list called ARR that comes from the source, which will be the summations of the adjacent elements. There we go. So ARR is going to be the new list every time, and then eventually it's going to get whittled down to 1, and then I'll just return element 0 of that list. So there you go, folks. And I need to, of course, return that sum, or no, return that element. There we go. And that's it. The list comprehension handles the repeated creation and summation creation of the list. And then this outer list is going to loop until it's 1, until the length is 1. Yeah, having trouble connecting today, but I got the code. That's all good. So run. That looks good. And that looks good. Correctamundo. Here we go. All right. So there's your code, kiddies. This one is Sum2total. And there's your solution. And now that we got a solution, that means time for me to break north. I am out.